Welcome to Insight Builder channel. Solopreneur's secret weapon. Developing microservices web app with agentic IDE like Cursor and Windsurf Codium. This is parts 7a. 4 key design principles of microservices. The question is, can agentic IDE build scalable web applications? Answer is yes, it can. Cursor-like agentic IDEs can build scalable web apps with the same efficiency as they can build regular web applications. So what is stopping us from actually building scalable web applications? Our understanding. Understanding what is scalable means and understanding what is the building blocks of scalable application and microservices is what we are going to see in this video. What is meaning of scalable? Ability of the system to handle an increasing number of requests by adding resources, typically in a way that it does not impact the performance of the system. This is what a scalable means. Let us actually dive in a little more detail. There are a couple of ways to do scaling. So there is vertical and there is horizontal scaling. When it comes to vertical scaling, you have only one server or one resource that you're going to make that resource stronger. Okay, that is vertical. Vertical is making things strong. Horizontal is the opposite. You are going to keep the resource that you have in the same strength, but you are going to add more resources. You are going to multiply the resource. So horizontal means multiply. And when it comes to horizontal, there is going to be a lot of challenges, but horizontal is very easy because you don't need to buy stronger servers. You don't need to buy or overhaul your existing hardware system. You need to just buy more hardware from the market and then add it to your network. It becomes much more easier, right? Multiplying things are far more easier, right? But the challenge there is to maintain the state. So that becomes a challenge. And that is where the entire microservices concept and the 4 key design principles that we are talking about, the software design principles, that comes into picture. Let's now dive into the 12 challenges in horizontal scaling and scaling as a whole. I am going to be very brief about these challenges. There are a couple of challenges I will dive in, but other challenges I will let you guys to explore. First, data consistency. It is very similar to the state management. The data that is going to be available between the varieties of services that you are going to develop and deploy has to be consistent. In order to create this kind of consistency, you need to have a certain kind of a communication that happens between the varieties of services that you're going to deploy. That is done through inter-service communication, right? And there should be a level of fault tolerance, like creating a redundant services. In fact, there are a couple of algorithms available for that also. You can actually look into those algorithms, look up those details in the internet. And there are a couple of videos already discussing these things. The point I want to make here is that to have an overview of what is required when you're going to develop and deploy a microservice, that's what I'm going to show you in a couple of minutes. We have the network latency. When you're going to have inter-service communication, the communication between the services has to be fast, or else your services might actually become much slower and the user might actually leave. So we have to maintain a reliability and the speed so that the user can keep using our service. Service discovery has to be fluent and it has to be seamless. The load balancing has to be managed when there is a sudden spike in the user request. We need to have a good monitoring and observability setup so that all the errors and the varieties of tasks that a particular server is doing is properly logged and can be used for auditing processes. Deployment complexity is something that we have to manage, and there are applications like K8s or Kubernetes that can help you to do that. The security has to be shared across the services, because once the service any service has to be accessed, it has to go through a security protocol. It has to go through a password and username authentication, right? So it's better to share it. And we have scaling bottlenecks that we need to manage. And finally, the technical debt. This is one of the major challenges that many teams will face, but you are not a team. You are going to work with the cursor IDE and you're going to develop everything by yourself, right? So the technical debt is technically not a challenge for you because you are going to learn and we are going to overcome the technical debt from this video. That is the purpose of this video, to overcome the technical debt that you might incur if you directly dive into microservices without understanding what is going on. Let's now move forward. We have seen the challenges, right? There are ways in which microservices help in this scaling process. Independent scaling, you can have the microservices developed independently and it can be deployed independently, and it can have independent ways of connecting with the database, so the services are decoupled, right? And the load balancing horizontal scaling becomes very, very simple because there are individual servers, individual databases, and they can talk with each other using the intercommunication protocols. So horizontal load balancing and auto scaling can be a very simple activity to do when you're going to use microservices. But all of these things depend on one important thing, the state management. You need to have a very robust way of managing the state in which the current services are in. You can do that with the help of Redis, RabbitMQ, and various other queuing as well as state management applications out there. All of these things can be implemented with the help of the agentic IDEs. You need to know that these services are available, these applications are available, and you need to practice with them. That is one of the ways you can manage the technical debt that comes up. Well, I've discussed about the scaling, the types of scaling, the challenges in scaling, and how microservices can help in scaling. Next, what you're going to do is we are going to look at the 5 steps to migrate a monolith to microservice. In this case, we still don't have an application, right? We are building an application with the help of agentic IDE, right? And what is the best way to build an application with agentic IDE? It is still best to build a monolith application. Get the monolith application up and running first. Understand how the application is performing. Understand whether the application is able to give you what you want. Do that first. And then once you are comfortable with the monolith application, once you are very confident about the features, then start going into microservices. That will be a very effective way of working with the agentic IDE. At the end of the day, if you ask for a microservice to begin with, yes, it will provide you the good microservice, but you will have a lot of things to control and a lot of things to tweak from the beginning, which can be overwhelming, right? So that is a suggestion, but you can always dive into microservices from the beginning. In order to go from a monolith to microservice, you can work on decomposing the application into independent services. So this is required in order to create microservices, right? You have to first of all divide the entire monolith. Then each services has to run independently. So that means you need to configure independent databases, independent front-end connectivity, and independent network traffic routing. All of these things you have to do it independently, and for that you can use varieties of configuration management and deployment services like Kubernetes or OpenShift, etc. The communication between the services is done over HTTP REST or asynchronous messaging systems like RabbitMQ and Kafka. Again, these things are managed as separate Dockers or separate applications that you can connect in the single server. Authentication is shared across the services using the OAuth 2 flow or using JWT tokens, whichever is comfortable to you. But this is going to be a separate service. Authentication has to be a separate service. And finally, deploy each service independently, scale them independently, and make them fault isolated. All of these things are the ways you can move from a monolith to a microservice. In order to move from a monolith to microservices, the 4 key software design principles that I was talking about, and which is going to be the subject for rest of the series of videos, is dependency injection, that is DI, decouples the components for easier migration to microservices. Separation of concerns splits the responsibility into modular services. Inversion of control helps to manage dependencies dynamically, and it helps you to get and identify the services that are available. And finally, open close principle allows you to extend the functionality but does not allow you to modify the existing code. So these 4 principles help you to do this migration from a monolith to microservice. Because once you understand how the monolith works, then once you start decomposing it, the decomposition process will involve all of these 4 key design principles. So once you understand this principles, right, that is going to be done in the next video. You will be able to properly write microservices using agentic IDEs. We'll be seeing some examples. There are a couple of more things that you need to understand before you dive into the actual code and start working with agentic IDEs. What is a domain? In case of microservices, a domain is defined by the business logic. It encapsulates the data it manages and the process it supports. These 3 things, logic, data, and the process, that is the key aspect of any service that you are building, whether it's a single monolithic web application or a microservice. In case of monolith, there will be many processes, many data points, and many business logic that is implemented in one single application. In case of microservice, it is all separated. The process of defining a domain. First of all, you can follow a domain-driven development. In this way, what will happen is you identify the logic, you identify the data that logic is going to work with, and then write the code for it. This is one of the ways you can use agentic IDs effectively for this. But you need to understand the 4 key principles that we already discussed, right? That is something that you need to still understand. You cannot escape that. Each service must have its own database and scale independently. Try to give a separate network bandwidth for each service. The domain can be defined based on the team responsibility, but in our case, we are going to have a single person, right? You are a solopreneur and you are going to make all of these things, all of the services, all of the implementations by yourself. So that is going to be no team, right? But yeah, when you're going to work on agentic IDE, it is better to segregate each service as an individual project and work with the agentic IDE in a divide and rule procedure. That will be much more helpful. And if one service depends on another, the communication should happen via well-defined APIs. You have to also develop APIs. So we will be discussing about these things step by step, right? And finally, when it comes to migrations, as I told you, initially you will be working on a monolith application, and you will be deploying the monolith application, and then you can move into microservices. So that is a better way for you to work with the agentic IDE. In fact, anything that is better in the real world can be emulated in the agentic IDE also. And in real world, it is always done like this. You create a monolith and then you migrate to the microservices. Some people do develop everything as a microservice, but they know ahead of time, or they know ahead of time from the other applications that they've already used, right? They are not trying something, finding something new. So in those cases it works, but in your case it's always better to go with monolith and then go to microservice. You can use the strangler fig pattern where you incrementally replace the features that your monolith has into individual microservices and then bring them up one by one. So this is a very risk-averse pattern, and it helps you to keep your service running, and at the same time you are going to test out the services one by one. It's very risk-averse and also mostly used pattern. The other one is a Big Bang migration, where your entire monolith is replaced with the microservices, a battery of microservices, which is little more risky because your integration with other systems might actually fail, and there's a risk of failing. So avoid this pattern. But yeah, at the end of the day, if you're confident, go with this pattern. So in this discussion, we have seen the various types of scaling. What is a scalable application? We saw the challenges in scaling and how microservices help in scaling. We dove into the 5 steps to migrate monolith to microservice. What are the various steps that you need to follow? We discussed and introduced the 4 key software design principles. We discussed on defining the domains and 2 migration strategies. I believe that this video has given you an overview on the scaling as well as how you move into microservices. and how to use agentic IDs. So that is one of the objectives that I had in making this video. So I believe that this video is a good starting point for you to dive into microservices based web application. Do leave a comment if you have any questions, and do leave a like and share it with others. With that said, stay tuned for the next video where we'll dive into the 4 key design software principles with examples. With that said, see you guys. Have a great time.